Greetings, math fans. All right, so this is a video for applications of vectors, and I kind of combined two different classes because I teach 438 and 408. So same examples. Number two is slightly a little bit different, but we'll get to that. But anyway, this is day 7 for 438 and day 6 for 408. All right. So the key to all these problems, math fans, is you got to draw a picture. Okay, and remember, we're using all our stuff that we learned with law of sines and law of cosines to actually calculate everything. All right, and we're doing some bearing problems. All right, and so hopefully you guys all remember with bearing problems, you've got to draw that bearing line, right? That vertical bearing line. So anyway, we'll get to those problems in a second here, but let's just get started with this problem. Okay, so Shannon is pushing a 2,000-pound car up a hill with a 2-degree slope. So I'm going to actually sketch a quick picture here. Okay, so this is 2 degrees, and I'm not very good with drawing things, so that's a car. Ooh, it's a very, very sleek looking car. Nice. Okay, so that's 2 degrees. You have to draw more than just this. And by the way, this is a right angle here. Okay, but you have to draw more than this. Here's the deal. So this object has got a downward force like this, okay? And it says how much force is required to move the car. Let me draw that arrow again because it somehow deleted that. So, and this is the deal. Here is the force that it goes to move the car. I'm gonna actually make this in red, okay? So that is the force to move the car. The downward arrow that I just drew, math fans, this is 2,000 pounds. So that is 2,000. So here's the deal. If you remember, I told you can take a vector and you can move it anywhere you want as long as it points the same direction and has the same magnitude. So that red vector right there, I'm going to actually move that right to here. Okay, it's parallel to it. It's got the same magnitude. Everything looks good. Okay, so now I'm going to complete this picture. And this is the picture you have to draw. So you definitely see the hill that I drew with the 2 degrees and everything, but truly that downward force is 2,000 pounds. I need to find that. I need to know how much force it takes to push a 2,000-pound car up a hill. Okay? So a couple things here. First of all, that 2 degrees is, in fact, I'm going to erase this just to make it a little cleaner. So that is 2 degrees right there, okay? And you have to figure out, well, which angle is 2 degrees? Well, let's actually talk a little bit about a couple things here. First of all, do you guys, since these two lines are parallel, do you guys agree that, let me use a different color here, this and this, these two angles, those are alternate interior angles, right? So you got our 2 parallel lines here. You got the slope of that hill and also that the red arrow I drew on the bottom, right? So those are parallel. And anyway, those angles are congruent. So that the green angles are congruent. So I'm going to use one more color. It's gray. Okay. This is a right angle. Okay. And this is also a right angle. Those are both right angles. Okay. Hopefully that's good. Okay. So given that information, that you know about those angles, so the green angles and the gray angles, then we can say, I guess I'll have to use blue again here. This 2 degrees right here, then has to be this 2 degrees. It's kind of like, process of elimination, right? So this is 2 degrees. So now we have the triangle that we need. You know that's 2,000 pounds going down there. You know that's a 2 degree angle. You know this is a right triangle. So guys, we're going to use right triangle trick. Okay, now I explained how to get that 2 degrees. What you kind of need to do is just when you see this problem, know that 2 degrees is the one on top like that. Okay, don't get confused and make that this green one on the bottom, the 2 degrees, and so just somehow get confused. But that top one is the 2 degree angle. Okay, so let me sketch this picture now. I'm going to do that back in black here. So here's my picture. Okay, and this is, again, 2 degrees. You know this is 2,000 pounds. and you're looking for x. All right. Now, some people say, well, Mr. Chris, can't you just use law of sines? Yeah, you can. I mean, sure, you're going to have sine of 90, right? Or you're going to use this angle. Well, what's sine of 90? It's 1. So you can, or you can just use just basic right triangle trig and say, hey, sine of 2 degrees equals opposite over hypotenuse. Okay, you cross multiply and put your calculator, make sure you're in degree mode, and you get 69.8, and it's pounds. Okay, it's a very messy 6. 69.8 pounds. All right, so here's the deal too. Let's say you messed up, and let's say instead of putting the 2 degrees there, you put the 2 degrees down by the green, and you made that angle, instead of 2 degrees, you made it 88 degrees. Here's the deal. This number would be an enormous number. You would get something like x is equal to 1,930 pounds. Okay, so guys, you're smart kids. Think a little bit logically. If Shannon's pushing a 2,000-pound car up a hill with only a 2-degree slope, do you think she really has to push 1,930 pounds? Probably not. Probably a lot less. If you ever try to push a car, you certainly don't have to be the same weight as the car. Now, if you're pushing it up a 90-degree incline, it's going to crush you. It's going to fall back on you, right? Or even a 45-degree incline, it's going to be like a lot because it's going to want to push back at you. But if it's only a 1-degree or 2-degree incline, you don't really have to push that hard. So this is a more logical answer. Okay, so don't think about answers. Like when I get annoyed sometimes when kids say, "Oh, what's the measurement of this angle?" and say it's -5 degrees, or how much force did you push on there? And they give a negative answer. It's just something unreasonable. So think logically. You guys are smart kids, so just make sure the answer makes sense. Okay, all right. So you'll see one of those, and by the way, you'll probably see every one of these problems on a quiz and test. So make sure you know what you're doing. All right. Number 2, Ryan and Nikhil. So these names are actually from the first year I came up with this worksheet, which I believe is 2009. It's a long time ago. So anyway, these are our old kids. Okay. So Ryan and Nikhil are trying to pull Mr. Curvis into the pool. Lousy kids. Ryan pulls on one of his arms with a 200-pound force, while Nikhil pulls on the other arm with a 250-pound force. The angle between Ryan and Nikhil is 40 degrees. How much force does Mr. Curvis need to exert so he doesn't go into the pool? Guys, you need, when you see a problem like this, when you're pulling, you have 2 different forces pulling from one spot, right? They're both pulling me in the pool. You have to draw a parallelogram. Please do not draw anything else. It is a parallelogram problem. In fact, I am just going to draw the parallelogram right now. And I don't even care if I make the forces longer or shorter. Okay. So this is my parallelogram, and here's my force. This is the resultant force. Okay? It's always a parallelogram. So draw it, a parallelogram. Always with these problems. If you try to do tip to tail, you're not going to get it right because it doesn't even make sense to do tip to tail when you have 2 forces pulling at you. Okay? So, let's make, this is, change the color here. This is Ryan pulling at a 200-pound force, and this is Nikhil pulling at a 250-pound force. Okay? So, it says, and the angle between them is 40 degrees. So this angle is 40 degrees, the angle between them. Okay? All right. And this is, if you want to look at it, this is me right here. They're pulling on my arm. Okay? So, you have to use your properties of parallelograms. It's really an easy problem. First of all, I need to find out how much force I'm exerting so I don't go in the pool. That's that red line. So think about that. That 250 right here is also this 250, right? Opposite sides of parallelogram are congruent. And then you have to remember your property, also another property of parallelograms is if that's 40 degrees, consecutive angles of a parallelogram are supplementary. So if that is 40 degrees, that means this is 180 minus 40 or 140 degrees. Okay, and then you're looking for x. Now the beauty of this problem is we got all the information we need right now. This is 200, this is 250, this is 140 degrees, and you're looking for x. So what are you using for this? The only thing I can use, because this is side, angle, side, the only thing I can use for this is law of cosines. So law of cosines. Okay, so we got x squared equals 200 squared plus 250 squared minus 2 times 200 times 250 cosine of 140 degrees. Again, please do not make a mistake and use sine. Okay, it's law of cosines, not law of sine, so don't use sine there. All right. Anyway, I'm just going to do all, you guys can add all that up, put it all together here, and x comes out to be 423.2 pounds. Okay? That's pretty reasonable. So let's think a little logically. Again, does this make sense? If Ryan's pulling at 200 pounds and Nashil's pulling at 250 pounds, what is the most that they could possibly pull against me? Well, do you guys agree if it's like tug of war and they're one behind the other, the most could be 450 pounds. And this is less than 450. So that's actually a good sign. And if it's a pretty close angle, it's 40 degrees between them. So most of that force that they're pulling, I'm going to have to pull back. That's why it's not too much less than 423, right? It's certainly less than 450, but it's still a great amount that I have to pull against them. So I got to pull 423.2 pounds in order not to go into the pool. That's brutal. Okay. All right. So you see a second part here, math fans. If you're in 408, I'm going to skip this. All right. Number 3. A force of 100 pounds makes an angle of 60 degrees with the second force. The resultant of the two forces makes an angle of 35 degrees with the first force. Right away, guys, you have to draw a parallelogram. If you don't draw the parallelogram, you're going to get it wrong. Okay, so let's do that. All right, so a force, this is 100-pound force. And let me draw the resultant here too, because I know I don't need a resultant. So I'm going to draw that in here. All right, so a force of 100 pounds makes an angle of 60 degrees with the second force. So I'm going to actually label this because otherwise it gets confusing. So this is first force, and this is second force. Okay, so anyway, a force of 100 pounds makes an angle of 60 degrees with the second. So let me do this in a different color here. So this is 60 degrees. The resultant, that's the red one, makes of the two forces makes an angle of 35 degrees with the first force. So this is 35 degrees. Find the magnitudes of the second and of the resultant. Okay, so this is all the information you're given. Plenty of information. You just have to kind of manipulate and draw, move sides and angles around using your properties of parallelograms. Okay, so what I'm going to do is I'm going to take that first force and I'm going to draw it right here on this side because I want to basically I need a triangle. This is a triangle chapter. Okay, so I'm going to move that 100 over there. So if that green is 60 and that part's 35, hopefully you guys see that this part right here is going to be 60 minus 35 or 25 degrees. Okay? And if that's 60, consecutive angles are supplementary, so that's going to be 120 degrees. All right? So let me draw that triangle now because we actually have enough information. Here's your triangle. We said this is 25 degrees. This is 120 degrees. We know this is 100. And that's all we know. Okay? But that's plenty of information. So I'm going to actually call this X and this Y, just to make life a little bit easier. Okay? Well, the first thing I'm going to do is I'm going to find out this angle right here. Of course, that's just super easy. It's 180 minus 25 and 120 is 145. So it's 35 degrees. Okay, so now we really have we have all our angles and we have one side, so we can definitely use law of sines to figure out both of them because we have side angle relationships here. Okay, so let's go ahead and do it. Again, this is all with law of sines. Okay, so we're going to do 100 over sine of 25, because that's what we know, is equal to y, we'll do the resultant first, sounds good, y over sine of 120. Okay, and cross multiply and solve, so y comes out to be 204.92 pounds. So that is the resultant. Okay, and the x is our second one, so let's just do that. It's just as easy. It's 100 over sine of 25 is equal to x over sine of 35. Okay, cross multiply and divide, and we get x equals 135.72 pounds. Okay, and that's our second force. Just keep them straight, guys. Okay, make sure you're careful of what I'm asking, because even on quizzes and tests, I might ask for the resultant, or I might ask for the second force, or I might ask for the first force, depending on what I give you. So underline what you're supposed to get, because I have kids where I ask for the resultant and they give me the second force, or vice versa. Okay, so don't do that. Just, whatever I ask you, make sure you give it to me. Okay, so anyway, that's really easy. I want to make one quick point though, math fans. I use law of sines, and I have the largest angle here. Okay, so why? If you guys remember back in the day, I said, hey, you cannot use the law of sines with the largest angle. So why am I using law of sines and I have the largest angle? Now, hopefully you're going to tell me, well, Mr. Curtis, I have the largest angle. I'm like, that's perfect. Okay, you can use law of sines when you have the largest angle. You just can't find the largest angle. There is no way I can do an inverse sine and get 120 degrees. It's impossible. Okay, so if you have it, you're fine. If you're looking for it, then you can't do it. Then you need to find, one of the other angles first. You look for the largest side and then find that largest angle, later, as opposed to with law of sines. Okay, all right, cool. All right. So now we're getting into some bearing problems. Boop, boop, boop. Oh, sorry. Okay. Dan the man is flying a plane at 600 miles an hour on a bearing boop, 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 of 165 degrees. So the very first thing you're going to do is you're going to draw a dotted line. Now, remember, it is a triangle chapter, so you're forming a triangle, okay? And these are definitely ones that you have to practice, okay? 165, what I would suggest, as opposed to drawing it really close to vertically down, extend it out a little bit like this. Just give yourself some room to see. So this is 165 degrees here. And it's 600 miles an hour. Okay, so that's our first vector. There is a strong 30-mile-an-hour wind that hits the plane. It is coming from. Notice the word from is underlined. Guys, you need to understand what from means versus in the direction of or towards. Okay, if I said I'm coming from 250, I'm just going to do a little side thing here. If this is, let's say 250 degrees is here. This is 250 degrees, okay? If I said I'm coming from 250, do you guys, that was pretty random, went away. Do you guys agree if I say from 250 and I'm here, this is 250, and if I'm coming from it, which way am I going? Well, you should tell me what means I'm going this way. So what you want to do is when you see the word from, go to that direction and then go the other way. Okay, it's one of the more complicated things, which I don't quite know why it's so complicated, but that's the best way to explain it. If it's in the direction, if it's from, that's the word from. We'll get to the next problem. It says it's in the on the bearing of or in the direction of. But if it says from, then you need to be you need to go to that place and go the opposite way. Just like if I said, if I'm coming from north, go to north, which is like up, right? And then go south because you're coming from the north. Or if I said, hey, I'm coming from grandma's house, that means you're at grandma's house right now and you're going back the other way, going towards home, right? Okay. So I'll get a little excited about this, but sometimes kids really get confused with this stuff here. Okay. Anyway, if you follow my directions, you will get the problem right every single time. Okay. So we drew our bearing for the plane. You always are drawing, for plane problems, you're always drawing another bearing line at the tip of the plane. Always. Don't draw it anywhere else. It's always at the tip of the plane. And the plane's flying, I even drew the arrow, right? It's flying this way. You always, always, always draw that bearing line at the tip of the plane. Okay, so now let me go back over here. It's coming from a direction of 250. So 250 is like this. So this is 250 degrees. And it is a 30-mile-an-hour wind. Okay, so notice I drew it 250, and actually, if I drew, I know I already drew the arrow, so I'm going to almost blot out the arrow here. Okay, that's a 250-degree vector, but it's coming from 250. 250 is the bottom left here, so that means it's going this way. All right, so and then think logically, right? If the plane is flying that way and the wind's pushing it, the resultant is going to push it more to the right. Right? The wind's going to push the plane more to the right. So if you leave the picture this way and you draw a line to connect it, it's wrong because you never have tip to tip. Never. It's tip to tail. So what you need to do is you need to take that vector and you redraw it. I didn't do anything with it. I just redrew it. I moved it, kept the same direction. This is the wind vector, and this is 30. Okay? And then we draw our resultant vector. That's it. That is the picture. Okay, you got to get it right. So I hate to draw because I'll erase it, but if you did this, it's completely wrong. If you look at the triangle now and you said, oh, there's your 30 and there's your 600 and you drew it there, I'd say it's completely wrong. You have tip to tip. I've never drawn a vector tip to tip, ever, ever, ever. Okay? So I'm going to get rid of that. The red vector, that is a resultant vector. So math fans, our goal is to find that red vector. Okay? These are, like I said, once you understand how to do them, so once you do the homework and you practice, you're good at it, but it just takes some time to kind of figure this out. Okay, so our goal, I know it's a little messy because I made some thick lines here, but our goal is to get this angle here. It's always going to be our goal to get that angle. And the reason it's that angle is because notice I have two sides. I need the angle between, because once I have that angle between, I have side angle side. I can use law of cosines to find that red vector. Okay? So, notice I gave you two pieces of information. I gave you 165 degrees and I gave you 250 degrees. You will always use both pieces of information. Always, always, always. If you somehow calculate this and you didn't use both pieces of information, it's going to be wrong. It has to use both pieces of information. Okay? So, this is pretty consistent, all these problems. What we need to use here, but watch. This is what's going to happen here. See this 165? Do you guys agree that if that's 165, that's 180 minus 165, or 15 degrees? Okay, so that's 15 degrees, and since these dotted lines are parallel, these are alternate interior angles. That's 15 degrees. So I have part of that blue angle that I'm looking for. Okay. I need to get the other part. I need to get this part now. All right. So see at 250? I'm going to use that now. I already used the 165. I'm not going to use anything more than 165. I've used all the information to give me that 15-degree angle. That's beautiful. To get this gray angle, look logically. Look what's going on here, guys. It's 250 all the way around. I know it's going to get a little messy, but that's okay. It's 250 going all the way around. And do you guys agree that if it's 250 going all the way around and this part right here is 180 degrees, do you guys agree that if I want to get this part here now, I just subtract 250 minus 180 gives me 70 degrees. So that gray part is 70 degrees. Okay, it's always going to be relatively easy to find out, but you just have to kind of understand what you're doing. Okay, so the blue angle, this nice little friendly blue angle, is going to be 15 plus 70, which is 85 degrees. Ooh, that's a nice warm day. Okay, that's it. So that's all you need to do this problem. Now, if I draw a nice little friendly picture, I don't want to run out of room here, but that's okay. So here's the picture. And this is 85 degrees. And this is 600. And this is 30. And I'm looking for x. Is the law of cosines. All these problems is we got to do the law of cosines. Pretty important here. Okay, so we got x squared equals 600 squared plus 30 squared minus 2 times 600 times 30 times cosine of 85 degrees. Okay, there we go. Don't forget to take the square root, and x comes out to be 598.13 miles per hour. There we go. That is the ground speed. That's how fast the plane's going. That's the red vector. Okay. All right. So I asked you two things. I asked you the ground speed, and I asked you the resulting course. I want you guys to understand the plane right now is going at 165 degrees. And what's going on is the plane, or the wind, is pushing it off course, right? When the wind hits the plane, it changes its course. So do you guys agree that if that's 165, this black line, I'll make it a little bit thicker now. So this black line was 165 degrees. And the red line, that's my new course. So what I need out of this is I need to see how much it went off course. So I need to find that angle right there, which if I draw it on the triangle here, it's that angle right there. So guys, this is pretty easy because once I have the 598.13, which you are storing in your calculator, okay, you have an opposite side angle relationship. So that 85 degrees goes with that x. So basically I have 598.13 over sine of 85 degrees is equal to 30 over sine of, we'll call that theta, sine of theta. Okay? You put in your calculator and you wind up getting theta is equal to 2.86 degrees. Now, math fans, if you put 2.86 degrees, okay, that doesn't even make sense. 2.86 degrees is this way. That's like 2.86 degrees. There is no way a 30-mile-an-hour wind is going to push a 600-mile-an-hour airplane that crazy amount. Okay, and that's what kids do. They like to put, they're like theta, 2.86 degrees. Guys, that's just the blue. That's how much is going off course. That's how much is altering the course. So really what your final answer is, so your new course is basically, you have to say, well, do I subtract or do I add? Well, look logically. Isn't the black line at 165? And what happens when I get to the red line? Isn't it 165? And isn't it less? 164, 163, 162, 161. Isn't it going less of an angle? Right? So again, I'm going this way. So I'm going less of an angle. So it's 165 minus 2.86 degrees. So my final answer for this one is 162.14 degrees. If the wind was blowing the other way, then you would add it. Just kind of, again, look at the picture. You're smart kids. Make sure you understand what the picture is, and then decide whether you need to add or subtract. Okay? So definitely, they're not easy problems. I'm not going to say that they're the easiest problems, but you have to understand there's a lot of little things you have to understand with this. That's why doing your homework is super critical, just to understand everything. Okay? So, and then I do have another video for the following, just another video where you can look at another set of examples to just to get a little more practice. Okay? Anyway, we have number 5, so let's do that. Okay. All right, so starting at the Coney Yacht Club, which I'm a member of, Shivani sails 15 kilometers on a bearing of 120 degrees. Boop, 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 bearing. Okay, so we're going to draw our nice little dotted line here. 120 degrees. So again, I don't like, well, this is 120 degrees, so it's kind of a nice one. So here's 120 degrees. Okay. And this is 15 kilometers, so let's label that too. Okay. Then she realizes she must go to Math Island, which I vacation there usually, to pick up some trig books. So she changes course and sails 40 kilometers on a bearing. Boop, boop, boop. So see where that arrow is, the tip of the arrow? That's where she is now. So she's changing direction. So you draw another dotted line there. And on a bearing of 325 degrees. So that's actually like this. 325 degrees. Okay? So and this is, and it's 40 kilometers. So this is, let me put a 40 here. It says, find the distance from Math Island to the Coney Yacht Club. So I'm looking for this distance right there. So it's kind of like she went 15 kilometers and then 40 kilometers. And I'm like, yeah, you know, I want to go straight to Math Island because, or I want to go to, yeah, she's going, let's see, starting Yacht Club. I have to look at it. She goes Math Island. Oh, and then it doesn't say where she's going after that. I don't know. Maybe she's going to some English island. Probably not. I wouldn't want to go there. Okay. Anyway, so she's right here. This is your final destination. And I drew the red arrow because that is a resultant vector. If you just wanted to go right from the Coney Yacht Club to whatever it is, Schmutzky Land or whatever you want to call it. Okay. So here's your picture, guys. And your goal is to find the distance, that red, basically the red arrow. Okay. Remember, you are always using both pieces of information. Always, always, always. And you're always, the angle you're finding is always going to be between the two sides. So I'm going to draw this in here. This angle right here. It's the angle between the 15 and the 40. You're always finding that one. Okay? I cannot stress that enough. So let's kind of use some of this information here. Do you guys agree that 120... again, there's a lot of ways to solve this. You can use supplementary angles, alternate interior. So many ways to solve this. I'm showing you one. If you recognize another one and you are using all your correct math, that is beautiful. Okay? This is what I'm going to do because I like alternate interior. I've been consistently using that. So this angle right here is 120 from 180, so this is 60 degrees. So if that's 60, this angle right here is also 60. Right? Alternate interior. Because it got the two dotted lines that are parallel. Okay? So that's 60 and that's 60. That's beautiful. And if you recognize, if that's 325, that, math fans, is 360 minus 325, which is 35 degrees. Hey! How you doing? Okay. So then if I want to find the blue, it's just the green minus the red. Kind of like non-denominational holiday colors. Okay, so basically the blue is going to be 60 minus 35, and that's going to give us 25 degrees. There we go. That's all I need is 25 degrees. So now when I draw this picture, just make a quick sketch again because I like resketching the picture. Okay, this is 25 degrees, and this is 15, and this is 40. And you're looking for x. And this is law of cosines. Okay, so let's do that. So it's x squared is equal to 15 squared plus 40 squared minus 2 times 15 times 40 times cosine of 25 degrees. So take the square root and we get x equals 27.16, and it's kerfometers or kilometers. There we go. Okay, that was a pretty easy problem. Okay, but just got to make your sketch really good and always find that angle between the two sides. It's just what it is with all these problems, guys. And use your knowledge of geometry, alternate interior angles, and then, you know, supplementary angles, and then law of cosines, and then you're good to go. Okay, so that was it. So anyway, I did 5 examples with you guys. Your homework tonight has got all 5 examples on there. Make sure you practice that and understand how to do all those. And like I said, there's the next video has got another round of 4 problems. One is pushing a truck up a hill. Another one's a first force, second force problem. And then I have 2 airplane problems. Airplane problems always cause the most issue. So I think it's a good idea to check those videos out as well. Okay? So that's it, math fans. You have an outstanding day. Adios. Goodbye.